In our first lesson, we learned how to read and evaluate logarithms. In the second lesson, we explored the product rule, quotient rule, power rule, and the change of base formula. Now it's time to put those ideas to work. In this video, we'll learn how to solve logarithmic equations step by step. Some equations can be solved simply by rewriting them in exponential form. Others require us to use logarithm properties to combine or simplify expressions before we can find a solution. We'll also discuss one of the most common mistakes students make when solving logarithmic equations: accepting answers that don't actually work. Because logarithms have domain restrictions, every solution should be checked in the original equation to make sure it's valid. We'll work through several example problems using the IUSC method, which means to isolate logarithmic terms, undo logarithms to form exponential equations, solve them algebraically, and then check by substituting back into the original equation. By the end of this lesson, you have a strategy that you can use to solve nearly any logarithmic equation you encounter in Algebra 2 or pre-calculus. So let's get started. Okay, let's begin with problem number 1. We're solving for x from the equation 4 raised to 2x minus 1 minus 27 equals 0. First thing I want to do is take the 27 to the other side. So I would have 4 raised to 2x minus 1 is equal to 27. We'll take the log of both sides. So the log of 4 raised to 2x minus 1 is equal to the log of 27. The power rule says that we can bring this exponent to the front of the logarithmic expression. So it'll be 2x minus 1 times log 4 is equal to log 27. Okay, let's distribute here. So this will give me 2x log 4 minus log 4 equals log 27. Okay, let's keep our x on one side and take everything else to the other side. So we would have 2x log 4, taking this to the other side, so I would have log 27 plus log 4. So I can say then that x will equal log 27 plus log 4 divided by 2 log 4. Okay, so in our calculator, I'm going to go alpha y equals, I'm going to say in the numerator, log 27 plus log 4 divided by 2 times the log 4, close parentheses, enter. So that means the answer is approximately 1.68872. We said then that x was approximately equal to 1.6887. So let's check this to see if it's correct. So if I were to say 4 raised to the 2 times 1.6 887 minus 1 is equal to 27. So when I enter this into the calculator, I get 27 equals 27. So then I know that this must be a valid answer. Okay, looking at problem number 2, let's go ahead and find the log of both sides. So I'm going to use natural log this time. So I'm going to say the ln of 4 raised to the 3x is going to equal to the natural logarithm of 6 raised to the 2x plus 5. Okay, let's use the power rule. So bring my 3x to the front. So 3x ln 4 is going to equal, same thing on the other side, 2x plus 5 times the logarithm of 6. All right, let's combine our x's to the same side. And we also need to just do some little distributing here. So let's go ahead and distribute first, and then we'll combine our x's. So 3x log of 4 equals 2x log of 6 plus 5 log of 6. All right, now let's bring our x over to the other side. So I have both my x's on the same side. So I would have 3x natural log of 4 minus 2x natural log of 6 equals 5 natural log of 6. I can say then, let's factor out an x. So x, this would be 3 ln of 4 minus 2 ln 6 equals 5 ln of 6. Okay, so I can say then that x will be equal to 5 natural log of 6 divided by 3 natural log of 4 minus 2 natural log of 6. If we're solving for x, I'm going to create a fraction. In the top of the fraction, we're going to say 5 ln 6. At the bottom of the fraction, we'll say 3 ln 4 minus 2 ln 6. Okay, that's going to give us approximately 15.57065, whatever, okay? So this gives us a value of x equal to approximately 15.5706, okay? So let's substitute it back into the equation. So 4 raised to 3 times 15.5706, I get 1.3286 times 10 to the 28th power. Okay, on the other side, if I say 6 raised to 2 times 15.5706 plus 5, I get again 1.3286 times 10 to the 28th power. So we can say then that this is a valid answer for the given equation. For problem number 3, let's start off by cross multiplying. Two times 3 raised to the x minus 1 equals 3 raised to the power of x. Okay, let's distribute, so that'll be 2 times 3 raised to the x minus 2 equals 3 raised to the power of x. Let's combine our x's to the same side. So I have 2 times 3 to the x minus 3 to the x equals 2. So 2 times 3 to the x minus 1 3 to the x will be 3 to the x equals 2. So the log of 3 raised to the x is equal to the log of 2. So I can say x log of 3 equals the log of 2. So x is equal to the log of 2 over the log of 3. And if you wanted to use the change of base formula, I could say that x is equal to log base 3 for 2. So let's enter this into our calculator. Okay, we could say that log 2 over log 3 that would give us approximately 0.6309 and change. Or if I want to go the other route, I could go math and go log base 3 or 2, and I would get the same answer. We got for a value of x approximately 0.6309. So I can say that 3 raised to the 0.6309 divided by 3 raised to 0.6309 minus 1. And if I put this in my calculator, it does give me 2. So we know that this is the answer. In problem number 4, we have 4 raised to the power of x plus 4 raised to the power of x plus 4 raised to the power of x equals 36. So notice that we have 4 to the x 3 times. So let's go ahead and factor out 4 raised to the x. That'll be 1 plus 1 plus 1 equals 36. So 4 to the x equals 36 divided by 3, which equals 12. So 4 to the x equals 12. So I could say x log 4 equals log 12. So x will equal the log 12 over the log 4. Now, since you can't easily turn 12 into a power of 4, let's use the change of base rule. So we could say then that x will be equal to log base 4 of 12. So on the calculator then, let's go to math. Let's go down to log base. So log base 4 for the number 12 equals 1.79. X is equal to 1.7925. All right, we could also do something like this. So X is equal to, we said log base 4 of 12. Well, that will be equal to log base 4 of 4 times 3. So log base 4 of 4 plus the log base 4 of 3. The log base 4 of 4 is 1 plus the log base 4 of 3. Right, to show that this is also a valid way of working the problem, we could say then that 1 plus log base 4 of 3 gives the same answer. And to check our work, we can say then that 4 raised to 1.7925 plus 4 raised to 1.7925 plus 4 raised to 1.7925. Okay, if I put this in a calculator, it gives me 36. So we know that this is a valid answer. Okay, on problem 5. Okay, let's use the product rule first. Okay, the product rule, remember, says that the log of v for m plus the log of b for n equals the log of b for m times n. All right, so I'm going to use that to combine this portion. So log base 6 for 2y minus 4 plus log base 6 for 4 equals the log base 6 of 40. All right, so I'm going to say log base 6, this would be 2y minus 4 times 4 equals the log base 6 of 40. All right, so let's multiply this out. So that'd be log base 6. 2y times 4 is 8y. 4 times negative 4 is negative 16 is equal to 440. Now let's use our one-to-one relationship because all these are all the same power, or excuse me, the same log base. So I can cancel out the log bases. So I have 8y minus 16 equals 40. So 8y equals 56. So y equals 7. log base 6 of 2 times 7 minus 4 plus the log base 6 of 4 is equal to the log base 6 of 40. That's the log base 6 of 14 minus 4, which is 10, plus the log base 6 of 4 equals the log of 40. Okay, so I can combine both of these using the product rule. Log base 6 of 10 times 4 equals the log base 6 for 40. So log base 6 for 40 equals the log base 6 for 40. So it checks out. So my valid answer is y equals 7. Okay, in problem 6. All right, we can say that 2 to the 2x is the same thing as saying 2 to the x squared minus 2 to the x minus 10 equals 0. Notice this is in a quadratic format. So to make things easier, let's let some variable, I'm going to say u, so let's let u equal 2 raised to the power of x. So now I can substitute, so I have u squared minus u minus 10 equals 0. So in a quadratic equation, minus b plus or minus b squared minus 2ac, minus 4ac all over 2a. All right, so u is going to equal negative, a is 1, b is negative 1, c equals negative 10. So u is equal to negative minus 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 10. All this over 2 times 1. So this is going to give me u equals 1 plus or minus the square root of 1 plus 40 over 2. So I can say then that u is equal to, I'm going to use just a plus instead of the plus minus. So it'll be 1 plus the square root of 41 over 2. We said earlier that 2 to the x was equal to u. So 2 raised to the power of x will be equal to 1 plus the square root of 41 over 2. We can say that x is equal to the log base 2 of 1 plus the square root of 41 over 2. The part in the parentheses here, this is equal to 3.70156. So I can say then that by using the change of base formula, I can say that x is equal to the natural logarithm of 3.70156 divided by the natural log of 2. So solving this in a calculator then, we could have the natural log of 3.70156 divided by the natural log of 2, and we get 1.888. So when we solve this on a calculator, we got x is equal to approximately 1.888. So we were to say 2 raised to the 2 times 1.888 minus 2 times, or excuse me, 2 raised to the 1.888 minus 10, it gives us 0. So a valid answer for x then could be approximately 1.888. Okay, on problem number 7, we need to isolate our x first. So let's divide both sides by 27. That would be e raised to the x over 10. So let's take the natural log then of 40 over 27. All right, so I would have the ln of 40 over 27. Okay, the ln of e cancels out, so it gives me basically x over 10 for the inverse properties of one another. Okay, let's isolate my x. So x is going to equal 10 times the natural log of 40 over 27. Okay, in our calculator, we will say 10 times the natural log 40 over 27. So it will give us 3.9304. So let's check that real quick and see if that's the answer. Okay, so let's say 27 times e. E is going to be raised to the x over 10. So we have this number here. I'm just going to go up and grab it so I don't have to key it in. Over 10. And it equals 40. So that checks out. So we were able to show then x is approximately equal to 3.9304. And we just checked it on the calculator, so we know this is our answer. So let's review what we've learned. When solving logarithmic equations, the first step is to look at the form of the equation. If there are multiple logarithms, use the product, quotient, or power rule to combine them before solving. After solving the resulting equation, always check your answers in the original logarithmic equation because logarithms are only defined for positive arguments. Some algebraic solutions may turn out to be extraneous or must be rejected. The more you practice recognizing the structure of logarithmic equations, the easier it becomes to decide which strategy to use. If you found this video helpful, please like the video, subscribe to the channel, and leave a comment with any questions or suggestions for future lessons. Thanks for watching, and I'll see you in the next lesson. If you found this video helpful, please be sure to check out other lessons on this channel. Please leave a comment, like, and subscribe. Thank you for watching.